we're going to be doing inscribed angles. We're on section 9.3. Let's get started. We're going to talk about some inscribed angles. Let's just describe them first. An inscribed angle is an angle whose vertex is on the circle and whose sides contain the chord of the circle. I want to remind you that you do have note sheets for this. I would suggest that you color code them similar to what you've been doing in the past. We have our inscribed angle here. Here it is. It's inscribed because the vertex is on the circle itself. Right here. On the circle itself. Next, we're going to come here. The arc that lies on the interior of the inscribed angle and has endpoints on the angle is called the intercepted arc. And here, that intercepted arc, we're going to bring that up. There's where the points are, and here's that intercepted arc, there in blue. Feel free to summarize this on your note sheets. Don't feel like you have to write exactly this word for word. All right, now we're going to talk about the measure of an inscribed angle, and this is called the measure of the inscribed angle theorem. The measure of an inscribed angle in a circle is half the measure of the intercepted arc. So we learned last section that if this was a, that's like a 40-degree angle here, then this was a 40-degree arc. Well, if this intercepted arc was 40, and then you have an inscribed angle, not a central angle, that would be half that intercepted arc. So this would be 20 degrees. That's what this says here. We have a second formula, and this formula is kind of just the backwards of it. If we knew this one was 20, if we double it, we'd know this and this are 40. So if you know the measure of, arc AB is twice the intercepted, it should be the central angle, twice the central angle. So the arc length is twice the central angle. I want you to realize that this is two formula madness, all in the same square. So if you want to look for it, it has this picture inside. Okay? I would suggest that you pause this video and go write that formula down in your formula madness. All right, here's another theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Both of those angles intercept AB. If AB is 40, then this angle over here is 20. And this angle over here is also 20 because they intersect this same arc. Okay? That would make them congruent to each other. That's one of your theorems on your page there. You might want to look over that one. I don't have, it's just one of your theorems. I believe it's on one of your note sheets too. Here's another thing we need to pay attention to. It's an inscribed polygon. This is like a definition. If all the vertices of a polygon lie on the circle, then, it should be a then right there, then the polygon is inscribed in the circle, and the circle is circumscribed about the polygon. Notice that this polygon is inscribed because all of the vertices are on the circle. That makes the circle, the yellow circle, circumscribed about the polygon. So let's take that a little further. Let's inscribe a right triangle. You just learned recently that if you had an angle, it's half the intercepted arc. We know that this is a central angle and it's 180 degrees. So that makes this outside 180 degrees, and if that's true, then this is half, so it's 90. And that's exactly what this inscribed right triangle theorem says. It says, if a right triangle is inscribed in the circle, then the hypotenuse is the diameter of the circle. It's also the converse is true. You will be writing that converse for your homework. In other words, if the hypotenuse of a triangle is the diameter of a circle, then, if you have a triangle, how did that go? If one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle. This is pretty incredible, I think. We have an inscribed quadrilateral, and if the quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So since this one is, we have all of its sides are on that circle, so it is inscribed. That means that these two angles add up to 180. And these two add up to 180. The converse for this is true also. This is a formula madness, so I would suggest that you pause this video and go write that in on your formula madness sheet. Let's do some of these together. We're going to do 19 through 33 odd. That was 19 through 33 odd. Here's number 19. The instructions tell us, state if each angle is an inscribed angle. If it is, name the angle and the intercepted arc. The way we know if something is an inscribed angle is if the vertex is on the circle itself and the end points are there on the circle. This is an inscribed angle, so yes. And the instructions say that if it is, name the angle and the intercepted arc. So we have an angle CAB, and the intercepted arc is out here, and that's arc, I'll put the arc after, CB. Okay. We're now moving on to number 21. Number 21 says, state if each angle is an inscribed angle. If it is, name the intercepted arc. Remember that the vertex must be on the circle. That vertex is not on the circle anywhere, so no, it is not. If it's, then we don't have to do any of that then. Okay, we're done. Let's do number 23. Number 23 says to find the measure of the arc or angle indicated. We know that this arc is 82, and if you remember from your theorem, that this in here is half the intercepted arc. The way I remember which way is it half and doubled, can you tell that this one is larger out here than this here? It's much smaller as it tapers down, so it's going to be half. So we're going to take 82 divided by 2, which is 41 degrees. We're going to find the measure of the arc and angle indicated. Remember that we have a quadrilateral, and the if this is let's see, we're looking for this one. We know that these two are supplementary, and we know that these two are supplementary. This is 80. And we learned that because that was one of our theorems, right? And so we need this here. We know this is 60, we need that one, right? Let's see, what else do we know? Now that's 70. How much is this one? Oh, this, let's go take some of this stuff off. So we're looking for this piece. If we know that piece, we can call that one maybe x. So x plus 60 will give us the question mark that we're looking for. Let's see. We also know that this part, that is 100. So if we double that, that's 200. We already have 60 of it. So that's 140 right there. So all of these add up to 360. So we've got 140 plus 60 plus 70 plus x gives us 360. That's 270 plus x equals 360. That will be x. When I subtract this to the other side, I'll get x equals 90. All right, so that means that this over here is 90. Now, a moment ago I said this, I'm going to have to divide this by 2 for it to work. So this area right here is what we were looking for, right? And that's 150. So if that's 150, this piece intercepts that, and it's half 150. So that question mark will be 75. All right, let's do 27. We're supposed to solve this for x. This one right here, the intercepted arc, is this piece. And this part's half of that. We know this part is 168, and that's 90, and the rest of that subtracted from 360 is what we have left. So we're going to have to take 90 plus 168 plus, I'm going to call this piece out here y. That will all equal 360. So, adding those together, we get 258 plus y equals 360. Subtract that to the other side, and you get y equals 102. let's give ourselves some room here. All right. If this piece is 102, and I take half of that, it will equal this piece. So we have 102 divided by 2 equals 2x plus 23. 102 divided by 2 is going to be 51. Move that to the other side. I mean, we're going to move the 51 to the other side. Oh, wait. I had it. I'm sorry. Let's look at this. Let's see. We're going to take this. That. I should have an equal there and a plus there. We are going to move the 23 over here, and we're going to have 28 equals 2x. Divide by 2, and x equals 14. Let's do number 29. Number 29, we have this arc here. Excuse me, this angle here is 43. It intercepts this arc right here. So all I need to do is take that times 2, and it will equal this arc out here. And that'll equal 96 degrees. All right, now let's do this one. Find the measure of the arc or angle indicated. Here's the arc we're looking for. There is not an intercepted arc for that one. But we do have some pieces. We have this one that's intercepted, right? So if we found this piece, this whole piece, we could maybe subtract this little piece out of there, and we could have the piece there. That's some ideas. Some things we do know is that this piece is this piece right here is 66. And we also know that this piece, let's do it in a different color, intercepts that arc. And we know that this is 62, so if we double that 62, 62 times 2 is 124. This piece here is 124. Maybe we can subtract that out. Let's see if we can try that. We know that these two are supplementary. So if I take 180 minus 62, we get 118. So this part is 118. Let's see what else. So that means that this is twice that, 236. So this whole piece is 236. And then if we subtract that 66 out, we'll get this piece in here. Let's try that. We get 170. that, let's get rid of some of these lines in here so maybe we can see some stuff. We have some measurements there. We know that this piece is 68, and if we take, and we know that this piece is supplementary to it, so 180 minus 60 is 112. Let's see how that helps us. That corresponds with this. I'm going to just kind of make it bigger than need be, which goes with this, right? So if I double that 112, that's 224. I'll have that part, and I know that this blue part is the 170, so I can subtract the 170, and I think we got it then. 224 minus 170 will give us what we're looking for. Whew, that took a long time. There might have been a faster way to do that, though, but that's the one we got there. Let's move on to the last problem. All right, this is the last one. We're going to do number 33. I want you to notice that this right here is on the diameter. That makes this a right angle. That also makes this 180 degrees. Since this is 55, its intercepted arc is twice that, which is 110. This 2x plus 13 corresponds with this angle, which goes with this intercepted arc. All of this adds up to 360 degrees. So we're going to call that y for a moment. 180 plus 110 plus y equals 360. This will be 290 plus y is 360. So we're going to subtract that to the other side, and y will equal 70 degrees. So this is 70 degrees, and that's half of it, which is 35. So that 2x plus 13 will equal 35. Subtract the 13 to the other side and you'll get 22. Divide by 2, x equals 11. All right, that concludes this lesson. This is what we've learned so far. You know that inscribed angles, when you know what inscribed angles are, you know that the measure is half the central angle. You know that triangles that have one side as the diameter, then they're a right triangle. You know that the opposite angles of an inscribed quadrilateral are supplementary. Make sure you copy your theorems into your postlet book. And make sure you also study for your Formula Madness quiz. I hope this has been helpful. Goodbye.